Hi everyone, my name is Zoltán Gombar. I'm a co-organizer and also head of Open Telekom Cloud operations here in Hungary. I'm happy to announce that we have renewed our OpenStack meetup community under the name OpenStack Europe. With that, we would like to foster international cooperation in OpenStack and cloud native technologies and solutions. At the beginning, we plan to have virtual events, but with the growing of the community, we even plan to have in-person or hybrid events for the upcoming months in the various cities in Europe. So what is the added value of OpenStack Europe besides obviously the open source technology? I think one important aspect for us is data sovereignty, which gains more and more focus in our communities. So I'm really great to join to this first meetup event where we will have topics dealing with automation, Kubernetes, OpenStack SDK, and so on. And just short listing of our presenters. We have a very good lineup. The first topic will be automate the full Kubernetes environment on OpenStack. My two colleagues, Vineet Pruthi and Ferenc Kukucska, will show this. And in the second part, best practices for automation with OpenStack SDK. Here, Nils Magnus and Tino Schreiber will be the presenters. So without any further ado, may I give the word to our first presenters, Vineet and Ferry. The floor is yours.
Hello everyone, welcome to our demo, full automated application deployment to OpenStack Kubernetes environment. My name is Ferenc Kukucska. I've been working in the Big Data and AI squad for 3 years now as an architect. Been in the AI industry since 2017. In these past 5 years, I worked on projects like recommendation systems, intelligent search engines, chatbots, but in the last 2 years, I'm focusing much more on the DevOps projects built with technologies like Kubernetes, Helm, and Terraform, OpenStack, and you will see each of these as a building block of our main application in this presentation. My fellow presenter is Vineet.
Thank you, Ferenc. Hello, everyone. My name is Vineet. I'm a senior DevOps engineer. My strong focus is on OpenStack Cloud platform, particularly the Open Telekom Cloud. I've been working with the OTC since 2017 and gained valuable expertise and hands-on experience on different DevOps tools like Terraform, Kubernetes, Helm, Ansible, Docker. I have also developed a deep understanding of the OTC ecosystem together with Ferenc. I'm really excited to be here today to share our journey and insights with you.
Thank you, Vineet. So here you can see a basic overview of our whole project. You might remember the COVID detection application from last year, which our team, the Big Data and AI squad, have developed. We demonstrated it in a few places, but never in this current form, which we will show it now in this OpenStack meetup, because we always have presented it from an AI perspective, but now we are focusing the deployment and on the security perspective. We will unfold each of these clouds and hexagons in the upcoming 30 minutes. So the slide mainly functions as a content of what you will see. Our project is quite versatile with many cool tools such as OpenStack, Terraform, Kubernetes, Helm, HashiCorp Vault. So let me define each of these in a few sentences on the next slide. I think most of you have already heard about Terraform, and many of you either used it, so I would just define it in one sentence. Terraform is an open source infrastructure as a code tool that enables you to safely and predictably provision and manage infrastructure in any cloud. So basically what this means is you could avoid the usage of Terraform by just manually logging into OTC, AWS, Azure, and clicking through all the stuff on the GUI console, like spinning up ECS machines and manage the load balancer, the VPCs, the keys, the configurations, creating databases. But you can also just use Terraform for provisioning all of this from code. So it's much quicker, I think much more automatable, and not to mention the code is reusable because of Terraform's modularity. So the code can be used even in future projects. I think Kubernetes is the most well-known from these. It's an open source container orchestration tool It's written in Go and originally designed by Google. It automates, scales, and manages the deployments and the containerized applications. I think it's a perfect tool for managing the large cloud native workloads. And by now, Kubernetes has become the de facto standard in application deployment. It's a fun fact that Kubernetes means helmsman in Greek, you know, the guy who steers the ships. So this tool Helm is a software that helps you manage Kubernetes applications. It's a package manager. By using Helm, you can use Helm charts. So the Helm chart is not a data visualization tool, but it's a collection of files that describe a set of Kubernetes resources. Helm charts make easier to define, install, and upgrade even the most complex Kubernetes application. Our main protagonist today is OpenStack, which is a free open standard cloud computing platform. It's mostly developed as an infrastructure as a service in both public and private clouds, where virtual services and virtual servers and resources are made available for the users. As you know, OTC is also an OpenStack compliant platform, which we will see a proof of in the practical part. So I think Vault is not as famous as the other ones, so I created a separate slide for Vault. So it's a secret keeper tool. If I had to compare it to something, I would say or tool that we use this Bitwarden, but Vault is like Bitwarden on steroids. It secures, stores, and tightly controls the access to the certificates, API keys, passwords, and tokens, and basically all the secrets in the cloud. So the secret management, I think nowadays it's a key requirement in the infrastructure as a service and also IaaS, IaaC field. One of Vault's, I think, coolest feature is dynamic secret handling. By that, secrets are handled and generated on demand to enhance the security. I would also emphasize Vault's easy integration with Terraform, AWS, OpenStack, and many other platforms and tools. And Vineet will tell you a more comprehensive and I think practical description in the demo section in a few minutes. So this is a slide which well describes our development process of the whole stack. So the step 0 was to start a Jupyter Notebook in model art development environment and cell by cell, importing the data set, processing the data, starting the training, making some prediction, evaluating the results. And basically, it's just like every AI task. So this is the prototyping phase. Once we were satisfied with the precision and accuracy, then we could save the model, dump the Jupyter Notebook cells Python code to a single Python web script, and just start the ECS machine, spinning up an ECS machine, and start a single web server there. So we created also a simple, minimal, nice HTML code with the file upload option. And once this was there, we tested it. The testing went properly. We containerized it. So we created a Docker container from it and imported this into model arts, this model management, model import section as a custom container, and then deployed it as a real-time service. So of course we used Git for version controlling during the whole development phase. Once our app was containerized, we created a cluster for it in CCE. This is the cloud container engine of OTC. And to make our life much easier and the Kubernetes YAML files reusable, we created some Helm charts for the app and inserted our secrets and all the stuff, config files that were confidential into HashiCorp Vault server, and also wrote some Terraform scripts to manage this whole infra automatically. So let's see all of these in action. Now we are in the Visual Studio, and as you can see in here, I have 4 sections: Bean, COVID, Helm, and Terraform. So I will cover the first 3, and Vineet will tell you about Terraform, HashiCorp Vault, the integration. So as you can see in here, this bin folder only contains some bash scripts, which basically, installing Terraform, creating some basic stuff, destroying the Terraform, logging into SWR software repository of OTC, building, tagging, and pushing a Docker image, installing the kubectl tool, adding some Helm repositories, installing the ingress controller of Helm. So basically, these are the scripts that helped us testing the whole thing, because, when we are destroying and installing and again, we need some scripts that speed up the whole process. So these are scripts for that. This is the bin folder, the COVID-det folder. I think it's the core of the whole web app because it contains the backend and the front end as well. So as you can see, here I have a static folder. In the static folder, I have some basic JavaScript files, also some CSS files. So, you know, these are for the web application front end, also some images and videos that were necessary for the websites. In the templates folder, I have a index.html, as you can see. So basically, this is all the HTML code for our application. And as I mentioned, we have an upload folder where we store all the pictures that the user uploads. So, you know, based on these pictures, we will predict if this is a CT image that is COVID-19, normal, or pneumonia. We have also a Docker file, as you can see in here. It's a very minimal one. Basically, what we are doing is just putting the local code into a container, installing pip, you know, the Python package manager, also the requirements.txt, which contains all the Python libraries that were necessary for the application, exposing the application on this port 8585. So we make it available from outside as well, and basically running the web server with this command. We have also this build and run container.sh, which builds, runs the application and maps it to this port. OTC credentials.py, as you can see in here, this is mostly IAM stuff. So project ID, username, password, also some authorization URLs. So this will be stored in HashiCorp Vault because it's confidential data. That patient.0, this is the last file that I want to talk about in this section. Basically, we are allowing what kind of files the user can upload. And here we have a function. As you can see, it's a pretty big one, this upload file function, which basically handles the file upload. So we are making sure that, you know, a secure file name, it has some file. So we have to have some file to inference on. As you can see here, the inference is handled by this one. So it predicts based on that user uploaded image, if it's a CT image that is belongs to a normal user, meaning that is healthy, a COVID-19 CT image, or a pneumonia. And what we are doing at the end is displaying this on the index.html. That's about it for the second section, COVID-det. And the third section, this Helm application, as you can see in here, as I mentioned to you, basically Helm is a package manager, and Helm chart is a bunch of YAML files. So in this chart.yml, what we have is just some basic metadata, API version, name, type, and so on. You might find this values.yaml file a bit more interesting because here I specify a lot of things, as you can see. How many replicas do I want to have in this application? Now one is enough. If you remember, you know, I defined the image that we store in software repository. This is the exact image. Here I can specify if I want a service account. So this can be familiar to all of those who worked with Kubernetes in the past. I can also define the service. So what port do I make it available? What kind of type do I use? Service type, cluster IP, load balancer, node port. Now we are using a cluster IP because we are making it available from within the cluster. This issuer type, as you can see, it's staging. So in the Git, we have this in staging. Now, as you will see in the browser, it's prod. So the HTTPS is fine. We are setting the staging because prod has a rate limit. And, you know, if we are staging, then we can play with it as much as we want, you know, restart it infinite times. So we are using it, making for sure that it's good and we don't have to restart it again. Everything is working fine. And then we can have trusted issuer, a trusted certificate. We have this ingress, as you can see in here, where we define the ingress nginx, you know, the reverse proxy load balancer stuff. So basically what we have SSL TLS certification, SSL TLS termination as well. Here we are defining the URL for our application. If you enter this to the web browser, then basically you can get our application. The auto scaling makes us available that we can replicate one instance or even 100 instances if we are on Black Friday or something, and the CPU utilization, CPU load is very high. What we can do, spin up more instances, more replicas, and this OTC Cloud authorization, as you can see, here we are specifying them data. You know, it's a good practice in these charts that we don't define the values here. We override the values here. We have these templates in here. As you can see, a bunch of YAML files that I mentioned to you. What is Helm package manager for Kubernetes? For example, this deployment.yaml. What does it have? As you can see here, all the stuff that the deployment should have in Kubernetes, but, you know, these double curly braces, which are placeholder values. So we can override all these values. I think I covered Helm. So with that, I would give the word to Vineet, so he can cover also the Terraform and the Vault integration part.
Thank you, Ferry. And thank you very much for sharing the informative overview of the application with Helm deployments and charts. And Now I will guide you through our use case of Terraform to set up infrastructure and install the application seamlessly. So we will primarily focus on the three main providers: Open Telecom Cloud provider, Helm provider, and Vault provider. So these providers play a crucial role in our infrastructure setup and application deployment process. So we are not just focusing on infrastructure, but also application deployment through Helm and secrets management as well. So step by step, I will show you all the how it is done. So let's first check the Open Telecom Cloud provider. Open Telecom Cloud provider is for interacting, as the name suggests. So this Terraform provider can easily manage your Open Telecom Cloud architecture or infrastructure. And you can, to initialize this provider, you need to set up username, password, domain name, all the credentials, same like OpenStack platform. So since we are OpenStack compliance platform, but I think we usually don't use this approach of setting up user credentials directly in the provider. We use environment variables like OS Cloud or OS token, so whichever fits you. So I'm using here, like in our application, we were using OS Cloud variable. So we provided the profile, and then it initialization went successful, and then we were provisioning our infra. There is a small example mentioned here that how you can use this Open Telecom Cloud provider to provision a server. So it requires the parameters same, like imagine you're calling a post API of creating a server, and you need to provide the arguments, parameters, their name, flavor, and image ID, and disk, etc. So all the parameters you can provide, and then it will provision a web server for you. In our platform, we are provisioning a network and everything. So during the Terraform apply, you will get a look of that. So we will now focus the next more crucial provider, so which made this whole automation successful, which was Helm provider. Initially, we used to use Helm CLI commands to deploy Terraform charts, and then we explored that, okay, there is a Helm provider from Terraform which can also do the same job. Actually, it works exactly same way how a Helm CLI command works. You can provide your configuration in the default place, and it can use that config file, or there is also possibility you can pass the parameters like host, cluster, certificate, client key, and etc. to authenticate. So these parameters are coming dynamically from the infra provisioning. So infra provisioned a CCE cluster, and after provisioning a CCE cluster, we were able to fetch the credentials of kubeconfig and pass it here. So the whole process is like interlinked like a chain to each other. So then it went super smooth for us. Here I provided a small example which gives you an idea how Helm provider can deploy a Helm chart, sample Helm chart ingress controller. So here you can see the similar parameters like I mentioned for a Helm CLI command. So you have to provide all same parameters, name, namespace, and also it can create a namespace for you. The chart, of course, the chart name is mandatory, but like you are seeing, repository and version are only required when you are using a remote package and you want to fetch it from a specific repository. You can provide which version of that Helm chart you want to install. So these parameters are not required if you are using a local Helm chart. So you can just give the path of that Helm chart. And here you can see set. Set is for also setting dynamic values or overriding the default values of a Helm chart. So I've used here set for, because load balancer ID, I'm also fetching after resource provisioning, and set here dynamically. You can also use a files. So if you have certain static, you know that these configurations are must required, you can keep them in a file and pass that as a files variable. So it will, this value cannot be repeated. Set can be repeated several times. So you can only provide once values file, but set can be repeated several times. If you are using a sensitive value, so I would recommend using a set sensitive, that your state file of Terraform are not storing those sensitive values. So I hope it is giving you some idea how you can deploy Helm chart. It's quite simple and straightforward. The next one, we will cover the Vault. Here, the Vault provider, so you don't have to initialize or set in the Terraform providers list explicitly, because Terraform and Vault are product of HashiCorp. And when you are initializing Terraform, so Vault provider gets initialized right away at the same time. Here you can set, just export the environment variables, Terraform address and token, or what kind of authentication you are using, user pass or token based. By default, Terraform always uses token based authentication, but you can use another type of authentication. There are several authentication which Vault supports. So this is mostly for interacting with Vault. Here in this example, you can see that it's just create the 3 phases of Vault I have shown here. You usually will write secrets to your Vault, and then the secrets which you have written, you will fetch those secrets and then use it for provisioning your infrastructure or deploying Helm charts. So for example, my Helm chart is using a OS token or username password of cloud. So I will fetch it from there. So as you can see, the saving of credentials is quite straightforward using a key value combination. So you can store it this way. But usually I think we are storing our credentials pre-storing and not storing on the fly. That's where it fits in more better. So in the last slide, as you have seen, that I've shown you that how we can fetch secrets and use it for provisioning our applications, deploying in application or provisioning infrastructure. So, but what if our credentials are being updated periodically on a daily basis? My security concern that my database password, I want it to rotate it every day. So what you will do, will you rerun that Terraform or Vault commands to fetch and reinsert credentials? I think that's not a good approach, and it requires additional operational management, and it's complex. So there is a better approach which Vault provides, that Vault can also do that job for you. It can automatically inject credentials to your application, and we will look at it, how it is doing that in the next slide. Here is a very, I will explain in a bigger sketch because inside there are much more steps, but imagine this is a two-way authentication mechanism. On the left side, you are seeing a Kubernetes board. On the right side, there is a Vault server. There is an application which requires to update secrets from this specified path, which you can see in the yellow box. And these secrets are being updated. So every day on the specific time interval, these secrets must be inserted here in my application. So what I will do in the Kubernetes, I will run a sidecar, which will be utilizing a service account mapped to a service account that I don't want to give it a full-fledged privileges to the sidecar. And then from a service account, I will put here certificate that Vault knows from which service account the request is coming. And then it will issue a temporary token to the sidecar container, which is a very lightweight daemon running. And then after getting a temporary token, it can fetch these credentials dynamic and provide it to application. So that's in a very simple way that on a periodic basis, this will keep updating your secrets. As I mentioned, we want to do everything fully automated. So Vault is also providing this module that you can configure your authentication on the Vault side and define a role. The role means that you want to limit your Vault when which path of the secret it should access. We don't want to give grant to any secret on the Vault server, only a precise path. So you can have multiple secrets path. So here you are on the Vault server, you are passing the Kubernetes IP and service account certificate, and here you're defining the roles from which service account and which namespace the request can come that Vault knows about it. So this all configurations happens on Vault, but Terraform is doing it. So it is also happening in a fully automated way. This whole parameters which you are seeing here are fetched from after Kubernetes is up and running. We just create their service account in the same sequence and then fetch those CA certificate from service account and provision here. So everything is connected here in a chain. Okay, the last part which I would like to cover is the OpenStack plugin for Vault, which actually brought our interest to Vault, which brought our attention to utilize Vault in this approach, which I showed you in the previous slide, that Vault can also inject secrets, dynamic secrets. And what OpenStack plugin will do, this OpenStack plugin will manage your secrets in Vault. So first time you store here root secret, and then it is automatically generating for you token. It can create for you temporary user. So based on your use case, imagine you want to do a integration testing and you need a credential for 6 hours or just few hours, and then you can define here some policy that in this role, that in this time duration, it will keep generating a token, and I will utilize that token and run my testing, and then this token can be revoked back. So it makes the whole process super secure and dynamic that you are using the secrets in such a flow. And many thanks to our ecosystem community that they have created this OpenStack plugin and ecosystem from our OTC, and this can be used by whole OpenStack Cloud users, that it should fit everywhere wherever OpenStack Cloud is used. And you can find the steps in this GitHub path, which I have linked here, to how to install and utilize this plugin. I hope it will help to make your jobs quite easy. Okay, let's see a quick video. I wanted to show this whole process through a live mode, but due to a limited time, I have pre-recorded the whole Terraform apply steps that will show you how this whole Terraform apply process worked. Okay, as you can see here, so I'm initializing the providers. The HashiCorp provider Kubernetes is coming whenever you're using Helm provider. It's also coming. Then Open Telekom Cloud provider and Vault provider. So these are the 4 main which we used. So this is just validating the configurations. Here I'm sourcing some environment variables. You might be curious what I have sourced, so don't worry. I have shown, I will not show the original sourced variables, but the example. So I have sourced the Vault address, Vault token, and OS Cloud. As I mentioned that this fits to interact with our platform. You can use OpenStack-based cloud credentials. The Open Telekom Cloud. So here I'm planning using the var file dev TF-vars. Currently, I'm preparing my dev environment. And for that, I've prepared a different TF-vars file so that I can work with different environments. It will do applying the whole infrastructure. So it's creating the, as I mentioned, Vault policies and roles can be also managed with Terraform. Then it's provisioning the Kubernetes cluster. It has already provisioned load balancer, floating IP for us. Then node pool. So this is, as you can see, super speed. It took although 6 minutes for creating a CC cluster and 3 minutes for creating the node pool. After that, it installed all the Helm charts. So let's have a quick pause to it. So as you can see, it deployed a cert manager for managing certificates. It deployed Nginx controller for managing our load balancer. Then it also deployed a Vault agent. It's not using Vault server, just a client, a small lightweight daemon. So it also deployed a chart which will work with our, and then finally our COVID detection application, which everything went with one apply command. So in the output, I have kept the kube config parameter to be fetched, can be fetched through output. So what you will see that the kube configuration can be generated just by one command so that you don't have to struggle and fetch kube configurations from the cloud platform. So, and after that, I can easily run Helm list and check all the charts, which you can see cert manager, Nginx, Vault. Okay, so yeah. Now I'm going to show you that how in the application the sidecar container is running. As you can see, this is the pod which is using a sidecar container, the Vault container, and I will show you the quick logs here. So I'm checking the logs of the sidecar container and in the COVID detection application. In this sidecar container, you can see that it is authenticating with the Vault server. After successful authentication, it was injecting the secrets on this etc OpenStack OSTAC RC path, and this secrets then my application can use and work immediately. So it will keep updating this path on every regular interval how we have configured. So we don't have to worry about secrets management and anymore. Okay, we are also managing, as Ferry already mentioned, that we are managing certificates and ingress controllers. So just giving you a quick look of that. Okay, thank you. So this was the quick session of apply of a demo. So I hope you have got that how we have completely automated infrastructure deployment and also managing the whole secrets and everything is now managed completely through one Terraform and with the help of OpenStack plugin. Okay, thank you. I will hand over back to Ferry and he will show you quickly about the COVID detect application, what is the use case and give you a quick glimpse of that.
Thank you, Vineet. So yeah, finally, we can see the web application itself, for which we trained a model in Model Arts and also deployed as a real-time service in Model Arts. So I think it's pretty easy and straightforward how this COVID that works. So on the development process slide, I describe you one solution. Now I tell you another one. So for COVID that, you can also utilize the Model Arts auto-learning function called XML. For those of you who haven't heard about XML, this subservice of model arts can be used by anyone without any AI knowledge, without any coding knowledge. The user has to only upload the dataset, the labeled chest X-ray or CT images into OBS, Object Storage Service. The XML just trains the model automatically, so learns the pictures with the corresponding labels. This means that we don't have to care about those hyperparameter tuning and everything like that. XML service will set all the hyperparameters for us. Then the user deploys his or her model as a real-time service. So after deployment, the model will be available as an HTTP web service. And finally, the user can test it by uploading a photo to the website or to the real-time service of model arts below the prediction tab. And the app will detect whether that uploaded X-ray or CT image has been taken of someone who has COVID-19, pneumonia, or doesn't have any. So with this demo, we presented Open Telekom Cloud's AI and DevOps capabilities as well. The application can be used by remote doctor services, medical companies in the future in the field of pulmonology, virology, and other fields as well. And with this application, we can also demonstrate to our users and customers how the different DevOps technologies, as you can see on this slide, like HashiCorp, Vault, Terraform, CCE, Kubernetes, can work together with artificial intelligence. So here you can see the COVID detection website. You can check it out yourself as well by entering coviddetect.otcservice.com. So once we have this website running, basically just as I showed you in the Helm code, you can find the online COVID screening demo part and basically just drag and drop an image. Let me show you a couple of these images, like this normal image, COVID-19 image, or pneumonia image. And once we have it, then it predicts if it's a pneumonia, a normal, or a COVID-19. So here you can see the online COVID screening demo. Let me just demonstrate with this COVID-19, drag and drop it, and here you are, diagnosed COVID-19. Let me just do with the other one, like the normal one, drag and drop, and that's it. Predicted, diagnosed, normal, as you can see. Thank you very much for your attention, and if you have any question, please feel free to ask them.
So Ferenc, related to your part, I got a question here, and it is asked if this project under an open source license.
So, you know, what we trained our data set is some COVID detection CT image. So yes, there are, I think, a lot of this kind of projects as well. So the images are absolutely open source, so anyone can use it and train a model, you know, deal with it, prediction, something, and train it as many accuracy and as much precision as is possible.
There was also another question, and it is, have you ever considered a product like Argo CD to get rid of imperative app installation on CCE?
Argo CD, yes. So as you can see, you know, we have a very, very versatile infrastructure. So with Helm and CCE and Terraform and everything like that. So the next step would be just, I told Vineet, I don't know, a couple of days ago that for the infrastructure deployment, I think it's almost 100%, but we need one more thing, which we are not so familiar with, which are these GitOps tool. So either Argo CD or Flux. I think we will have a look next week, next month, and you know, if we have some time, utilize it because we are really interested in these GitOps, GitLab CI/CD solutions. Yes, thank you.
Okay. Last question for this section. Can this deployment be used for applications other than AI applications or on AI focus?
As I mentioned, this whole infra is very dynamic, and let me show you very quickly that how dynamic it is. Terraform is converted to modules approach. So these modules are super dynamic and they can fit anywhere. So these modules don't need to be like precisely for this specific COVID detection application. So you can use this module for and pick up one of whatever modules you need. So by using this modular approach, you can provision any kind of infrastructure, any kind of application. And this Helm charts are also very dynamic, and just by few adjustments, they can fit for another application deployments. So the answer is yes, we can make our existing, this was just for prototyping, but it can be fit for another deployments as well.
Last question, can this deployment be integrated with a CI/CD pipeline?
Yes, we have already done that. We are using, initially when we started to develop this Terraform, we were using CI/CD pipelines, but then we also evolved. So now our pipelines also look a bit more complex. The container building pipeline is happening separately, and then Terraform deployment, but they both have also integration to each other through CI/CD. So this can fit very much to pipeline approach, CI/CD approach.
The Next question is, what is the future scope of the COVID detect AI application?
There are those CT image and X-ray images as well. So I think we can use these images in other parts of the health and the medical field as well, because actually we are already preparing for the World AI Summit 2023, and we are working, I think, on two solutions. One is them regarding this nature consciousness. So plant disease prediction, where the user can upload a plant, a leaf, a tree, or bush or something, and our application can predict and decide if it's healthy, not healthy, disease, what kind of disease it has. So if you think about it, basically it's an image recognition, object detection tool, so our whole infra is for that as well. But there's also some air quality indexer, which we will take, I think, in the World AI Summit. So these can be all solved with the current infra as we have now.
And the last one is this project available on GitHub?
Not yet, but we will just remove the sensitive content from the GitLab and then upload the modules, which I already mentioned. We have modules architecture, and then it will be available on GitHub.
Welcome everybody back after this short break. Doing automation is cheap talk, but getting actually started on the task can be tricky at times. But we have seen now a lot of application-based automation in the previous talk. In this presentation, we are focusing a little bit more on the actual infrastructure, so one department below that, which is also important, especially from the perspective of platform engineer. And that's what we are talking about today. My name is Nils Magnus. I'm a senior cloud architect and community reach out manager for the Open Telekom Cloud. And together with my team, we are creating tools, libraries, and utilities that hopefully makes the life of cloud users and cloud customers for the Open Telekom Cloud easier. Together with me is Tino. Tino, how are you?
Hi guys, my name is Tino Schreiber. I'm cloud architect at Open Telekom Cloud, as Nils also is in my team. I'm developer for Ansible modules and some other cool tools like the Python OTC extension, which we will explain in a later step. And I'm also automation engineer and responsible for some infrastructure stuff of the Open Telekom Cloud. So today we have an interesting task brought with us. This is a typical task which might face by cloud engineers, and we want to retrieve an overview about every disk in our domains. And this is interesting because we have to fetch all of our projects and all of our servers, and with the list of those disks, we might get some further information, for instance, which type this have and if we might migrate them, and all the steps which are needed to query those disks will be shown in a later step. But how we can solve this simple challenge? One would be that we look up the information in the web UI. As you can see in the picture below, you can simply list them, but this is of course time consuming and error prone. And maybe there's another nice option which might be explained from Nils.
So my alternative would be to externalize tasks like this to a Python script or to some other scripting language. But as Python is the programming language of OpenStack, and OpenStack is the base for Open Telekom Cloud, why not using this existing OpenStack SDK? This has several advantages. So especially it makes tasks really repeatable, and you can document it by that, and you define a reference for future colleagues, for example, who will face the same challenge. But let's have a look for today's agenda a little bit. We started already with why automation makes sense. That's probably common sense. And we have a short look into the OpenStack SDK. We'll install and configure it. And then the main part of the presentation will be number 4, the live coding. After a very quick wrap up, we are here for a Q&A session. But let's dive directly into the SDK itself, Tino.
Sure. The OpenStack SDK itself is a library which is written in Python, as the most part of the code of OpenStack. And this library encapsulates all the individual API requests into Python objects and method calls, which can be used by further applications like the OpenStack client and, for instance, in scripts like we are doing in a later step. On the right side, you see the OpenStack SDK's documentation, and we have also the link below. And yeah, this can be used. Maybe it's interesting how you can install it to use it in our script, and this will be done by Nils, and I will hand over to him.
So this is the first demo time. So I'm logged here already into a freshly created ECS instance, so a virtual machine with nothing installed except of a brand new Ubuntu 22.04 or something like that. I go to my development folder, and first I start off with creating some virtual environment, creating a sandbox for my experiments here. So let's call this just project, and this takes about a second, and after that I can activate this sandbox in project bin activate, so that I don't get confused with other installed Python packages here. And next is then already the installation of the package that I need. Install, and it's just called OpenStack SDK. Additionally, I installed two more packages like the OTC extensions and a Python OpenStack client. The first is an extension for the specifics of the Telekom Cloud itself, which are not for functions which are not covered by OpenStack itself. And the Python OpenStack client is the command line tool that you can use on the command line if you want to query, say, for a list of servers or something like that. But today we are focusing on doing all this directly from the Python level itself. So what we can see here is the installation of all the dependencies. That takes usually just a few seconds, and just to cross-check, I'm invoking the module, which is called OpenStack without an SDK, and I can check the version, for example. Yeah, as we can see here, we have version 1.2.0, and this is a pretty recent version. Let me switch back to the presentation at this point. And what you can see here is we created demo time transcripts for all that we did in the live demo, so that you can just look this up after the presentation as well. So I can skip this and move over to the configuration. How do we connect to the cloud, Tino?
Yeah, it's important to know that we have also credentials to connect to your environment. There are several ways. We could recommend the way to use the Cloud's YAML file, which has all the credentials inside. There's also a secure YAML file where you can store the password beside the other parameters. And all of these files can be stored in various specific directories. In our case, we use the same folder as the script is in. Such a Cloud YAML file can contain several sections and parameters. In our case, we have all the content listed here. We split it up in two sections. On the left side, we are seeing the so-called project scope token section. This is the section where most of you guys might know such a configuration file. When you trigger the request towards the cloud, you will get back a project scope token. It can be used to query, for instance, servers, disks, volumes, etc. And on the right side, this is not so well known by everyone. There you get the domain scope token back, and there you have to provide an additional parameter below. And all you have to do to invoke the whole profile is to change the username, password, and of course the domain name in this case. So in our case, we want to fetch the projects of our domain to get all the disks inside. And to do this first, we need a domain scope token, and Nils will show us how to invoke this in our script. There's also another possibility. You can use those section names. On the left side is OTC project, and on the right side it is OTC domain in various options like in environment variables and also inside of your Python script, which will be shown by Nils.
All right, so the important parts now to remember are the two keywords, OTC project and OTC domain. We will start with OTC domain right away in our second demo time. And here we are back on the project, and I will do some live coding directly in an interactive Python shell so that we can see immediately what we create here and how to receive results and objects and so on. So we start right away with importing the package itself. And while we add this, just for convenience reason, I'm also importing the JSON package and define a short prettifier function. Let me do this. This has nothing to do with the OTC itself. Let's print a JSON dump string of the object, and let's indent everything with 4 characters so that this looks a little bit nicer. Now we have imported, we have prepared the scene, and we can connect to the actual cloud. And for that, we instantiate the OpenStack object with the connect method. And here we can select which cloud section we are looking for. And this is where I have to put the OTC domain keywords. Let's see if I typed everything in correctly. Yes, it looks good. We received the connection object, and let's save this in a domain object, domain scoped token object. No, that was also domain, right? And the domain object has now
You have a typo there.
Domain.
It's not domain, it is domain. Yeah, right.
So this is all live. Domain and the identity service, also known as Keystone for OpenStack users, is one of the services that are provided by the domain scoped tokens. And you see, this is a so-called proxy object for the service. And with that, I can retrieve resources like projects. A project is a resource, and with the plural as, we will retrieve a whole list of them, as we can see here. And this is actually not a list, but a generator object. It's an iterator so that we can piece by piece collect all the results. So if we want to do this, we could, for example, create a list from that. And then we can see we receive lots and lots of data. This is a little bit difficult to read. Let's just pick the first of those list items. So you can see this is the actual data, and now we can make use of our prettifier function. Pretty, and you can see this is a definition, the internal definition of a project. For us, most of the attributes are not so interesting, but the ID is and the name, they are both important, and we should store this into some extra variables. And let's call this our projects. And to do that, we can iterate the list of the results. And for this, so-called Python comprehension comes in very handy. So let me show you how to do this. You just write a for loop for project in, and now we have to reuse the code that we used here already. Domain identity projects. We iterate over that, and for every instance of the project, let me return its ID and the project name in a tuple. That's why I have also put on the normal braces around that. Let's check for the results. And here we can see, let's prettify that again, our project. What we Extracted here are lists actually of IDs and real project names. From this project name, we have now to jump to the next type of resource, which are the servers. What kind of servers are inside such a project like EUDE Vault? And for that, we need the second type of project, a project scope token. And for that, we have a convenience function on the so-called cloud layer directly connected to the connection object. And domain, I write a domain, and that is called, let me see, connect as project. And for that, you have to provide a project parameter. And let me keep this one here. So I need to that as well. And let's see what we receive. We receive another connection object for that. Let me also put this into a variable, project scope token, PST. And with the PST, which is, by the way, not possible with the domain scope token, we can now access the compute proxy, and the compute proxy has support for example, it's the servers function. And then we again get a list of a generator iterator of the servers, can filter out, say, the name and the ID. And let's have a very brief look at that. Let's create a list from it. Let's extract the first, and let me also prettify everything here. Okay. Yeah, there's a null value. Maybe that is a bad example. However, it is possible to access those attributes directly, like its ID, like this. Whoops, and here we go. So this is the ID of the first server. We didn't fill in all attributes in this demo domain here. Next question is, if we have such an ID or a name, which is working just in the same way, how do we get the list of the actual volumes? And for that, we have again project scope token on the compute service, the convenience function volume attachments, and that needs a server named attribute, which we use for Vault AG. And with that again, there's another generator object, and this now contains volumes. The volumes create the names, the IDs, and as well as the type of the volumes. And now we could filter, for example, for the old volume types that we want to migrate to the new one. But I won't do this all live, but switch back to our presentation slide. Since we collected everything in a single script, which is printed here, we have also put this into GitHub repository. So if you want to check this out, it's even open source, but it's a very short script, but everything is in there, and you can check out the full script there. To see also what the script actually creates, you see this is the text form, which step by step iterates over every project. So the list is much longer in our domain. It then iterates over the different servers. And the servers have, well, most of these servers have just one attached volume, but others may have more of them. And you also can see if there is user information that is also listed by our script here. This is a very short overview of the key principles of the connections and the comprehensions I talked about, so I can skip it here. This is once again a repetition of the dealing with the different types of tokens and how to filter out this stuff in Python comprehensions. So just to look this up again if you want to do it yourself as well. And we have obviously used some special features, some special methods of the various resource objects, and they are all documented in the Help Center. So you can find information about the services. We have in the OTC more than 50 services about compute, network, storage, and whatsoever. Several resources per each service, and several types of functions that you can apply to them. Everything available in the Help Center. And this is the main wrap up of the session, summarizing everything from importing, connecting, iterating over several layers. You see the pseudocode down there. And the remaining step left as some homework, if you say so, would be to extend the actual migration from a volume. No? So we could filter now for old SATA volumes and replace them with SSD ones, something like that. With that said, we say thank you very much for attending our short session. Please feel free and check out the information that we have here in the resources. So for example, our GitHub repo with lots of projects, not only Python-based, but also in Go and other languages, our community portal, the Help Center itself, and the upstream documentation for the OpenStack SDK project. Thank you very much. I don't know if there are any questions.
I got a question here. It is, does OpenStack Connect support any kind of security authentication and encryption such as TLS, etc. related to your part, Nils?
Indeed, that's all built into the SDK itself. So the connection to the actual service endpoints is by default secured by TLS. Another way to secure the authentication is to use authentication plugins, and there are several available. So we used here just a simple username password, but others are available as well. For example, so you can TOTP tokens, so that you use something like Google Authenticator or similar apps on your smartphone to create one-time passwords. It depends a little bit on the use case. So if you do something which is interactively run, like our short script, that makes sense. But if you do something which is running unattended, then it's not very helpful to have something like a TOTP authentication connected to it. But in theory, that's possible, indeed.
So also another question, it's also the same topic. Is it possible to authenticate in the script when multi-factor authentication of a user is enabled?
It is indeed. If you do so, you pass an additional parameter at the connect method. I think it's called passcode. So if you're able to get or generate somehow this passcode, that is possible. And you have to configure it, of course, in your Cloud's YAML file.
We've got a last question. This is the SDK also available for other programming languages like Go, Rust, or Java?
Would you like to answer it directly yourself, Tino? Or?
Sure. We have also the Gopher Cloud. This is quite common, and the rest of those. I might remember there was Java implementation, but I'm not sure if this is really used. But the Python-based one, so the OpenStack SDK and the OpenStack SDK for Gopher or the Gopher Cloud is well known and also used in a wide space. I'm not sure if you might know additional one, Nils?
Yeah, I think there have also been JavaScript and PHP implementations, but basically the same applies to as to Java. Maybe these are two different domains of expertise and working. However, I'd like to add something to the Gopher Cloud library. The Gopher Cloud library is more or less the equivalent of the OpenStack SDK. And the Gopher Cloud library is heavily used by both the Vault as well as the Terraform providers that Ferenc and Vineet just showcased to us. So those are the basis for those tools. And the same applies, by the way, for the OpenStack SDK, which we had a look into today, for Ansible. So there's a set of Ansible modules put together in a so-called Ansible collection, which can be installed, and then you can utilize Ansible playbooks to access all those functions that I just presented here. And you can do automation if you want to of provisioning servers, volumes, networks, security rules, whatsoever, and the actual application configuration in one single Ansible playbook, if you want to do so. Choice is yours and you're up to.
So there came another question in. Is it necessary to install a server-side package to use the OpenStack SDK itself? So I will answer it by myself. No, you do not have to install anything on server-side because the SDK invokes the APIs and encapsulates all the requests and all the session handling in one package, and all those APIs which are available from server side will be invoked by this tool or by this library. And so you do not have to install anything on server side.
But on the client side, there's actually a lot of magic happening in the library. So we briefly mentioned it in the presentation, but this is the major part of the SDK itself, doing the different types of authentication, doing the right types of encryption of the connection, setting up everything and doing some cross checks of validity of the data and so on, automatic service discovery, for example. So looking up the right API REST endpoints to access the services. This is all encapsulated and covered in the SDK itself.
So we got another one. Why uses the example code this somewhat unusual structure in the Cloud's YAML file? Why can I not just use my normal template? I think this question focuses on the both section, on the domain and the project section, as we have mentioned before. So the structure of this Cloud YAML file or the credentials itself can be different. So there are different options. You can invoke also not the user domain name. You can also use the project ID. So there are a couple of options, and those are explained in the OpenStack SDK documentation, and we follow up our example file here, which is for you some kind of a template who has never seen such a Cloud YAML file, and you can simply copy it and paste in your own user data, and that's it, and can use it by yourself. So I repeat what I said before. On the left side, the project section, which uses all the stuff, all the credential parts to query servers, this volumes, etc. on project level, and on the right side the domain stuff. So everything comes in place when it comes to users and project itself. Sure, you need to have appropriate permissions for sure, otherwise it won't work. But if you have those, you can use the specific section for your purposes. Is it also possible to migrate the volumes that are identified as outdated to a newer disk type?
Sure, this is possible, but this is obviously not on scope of this project because you need some extra insights of how you organize your volumes. So you have to format your volumes yourself, or operating system does this for you. And we have no knowledge, and the cloud has no knowledge about the file system and the file structures and so on. Once you know that, say if you are using always X4 file systems, then it's relatively easy to migrate an existing, creating a new volume and then copying from one to the other, or maybe using some backup mechanism, or there is a lot of choice and options available. But as I said, let's take this as a homework for an upcoming session, or maybe some of you want to provide something. We are open for pull requests on our GitHub repository.
Does the SDK support the creation of resources as VMs? Sure, you can do with the OpenStack SDK everything you can do with the API. For sure, there will, or sometimes it needs some time if those packages and proxies are updated and the lower functions and methods which uses those APIs, but for sure you can do everything you want with those, with the tools supported.
At the moment, we have basically 99% parity of the SDK functionality and the API functions, I'm pretty sure.
So let me also grab the opportunity to express my gratitude towards our great presenters and also to the excellent audience. You had lots of inspiring questions, and I wish to see you all at the next meetup event. Thank you.